agrees that we record. Online participants have no objections. Oh, okay.
Good. Yeah, so I will give this presentation on potentially most important environmental issues related to atmospheric air pollution in Iceland. And it's a presentation which I prepared, but I'm really happy to have the Icelandic representative from very important Icelandic institutions monitoring air pollution also here in the room. So anytime, please just add something to the points I'm showing if I forgot or if it's not correct. So let me proceed to the second slide. On behalf of the CAMS project, we are actually leading here. So as you can see, there are 5 issues I have chosen in terms of air pollution. And the first 2 I would consider as a major here in Iceland, and that's the erosion and active volcanoes. But we still have also environmental issues in terms of greenhouse gas observation and emissions. And then we have anthropogenic sources, of course. And then I added the environmental issue number 5, which are the additional sources, which might not be even known, but according, like looking around and living here for certain amount of years, I just added them. So the environmental issue number 1 regards to the large erosion areas in Iceland, because 40% of Iceland out of 100,000 square kilometers is the eroded area, which is very prone to erosion. So although Iceland is actually less industrialized country with quite low number of in population, we still have the natural sources of the air pollution here, which are as well as important as the anthropogenic one, and in certain cases also even more important. And yeah, when we talk about, for example, the particulate air pollution in masses around the world, it is 90% of the natural air pollution, which is in the atmosphere. So that would be the deserts and active volcanoes here, and then also important sources would be wetlands, and Iceland is surrounded by ocean. So also ocean is important source of both gases and particulates, and also very important sink of them. So for the air quality monitoring stations in Iceland, I have borrowed this slide from the Environmental Agency of Iceland, showing the location of the stations. Amazing news is that they are indeed increasing in numbers. But when it comes to my research, which is the desert areas, you can see compared to the map we are preparing together with the Land National Survey of Iceland, are not really monitored. And that's why during this project, we also chose the in-situ support from CAMS to locate 3 particulate matter stations, one in Northeast Iceland in the desert area and 2 in South. The second environmental issues, and you probably know about it, is of course the active volcanoes. We both have here explosive and effusive eruptions. That means that some of them don't actually produce any volcanic tephra. And I just chose example already of all the eruptions, although we have had now 7 eruptions in past 3 years. And some of them actually on multiple places. So Bardabunga Hollow Rain eruption 2014-15, which lasted, I guess, 6 months, if I'm correct, released about 11.8 megatons of sulfur dioxide, 5.6 megatons of carbon dioxide, and 0.1 megaton of hydrochloric acid and some hydrogen fluorides. And if you look at amount of these gases, the SO2 gas flux was actually more than the anthropogenic flux of SO2 from the whole Europe in 2011. And it was similar to the annual average of CO2 gas emission from all the Earth volcanoes. So natural sources of air pollution are extremely important. And I'm not saying about the impacts when it comes to the condensation of the gases and reaction with water, then you have sulfuric acid, which in terms of also impacts in terms of acid rains, and then of course the low pH of water in rivers around Iceland. And the other types of eruption, the explosive eruptions producing enormous amounts of volcanic tephra material, and this can actually be mixed with local dust sources. So we measured after the eruption was declared as closed in 2010 in Eyjafjallajökull, I think 3 months after the end. We measured just over 23 hours, 11 tons of dust to be transported over 1 meter transect. In 23 hours, it was really, really bad dust and sandstorm. And that lasted 23 hours. Some of the winds actually exceeded hurricane speeds. And if you took it all over the area which was affected by the storm in southern Iceland, actually there was about several hundreds of thousands up to 1 million tons of dust transported just during this event. And there are several events like this in Iceland every year. Although it's only dust, but this was mixed with the ash. And that's why the ash actually doesn't stay in Iceland very long after the eruption. We have the strong winds, so it's removed. So very often it happens that when we talk about the dust, people still consider it as a suspension of volcanic ashes, but it's not, because the majority of the dust actually comes from under the glaciers. Then for the volcanic gases, and also of course anthropogenic air pollution gases such as SO2 or hydrogen sulfide, you can see the station of the environmental agencies of Iceland is much more dense and well distributed around the country. And then we have the greenhouse gas monitoring here in Iceland, and that's what was Professor Joe Prospero talking about yesterday in terms of the measurements of dust. So in a small island south of Iceland, Westman Island, we have this NOAA ESRL Global Monitoring Division of monitoring the famous greenhouse gas curves you see in every climate report. The longest from Mauna Loa in Hawaii. So in Westman Island, we have this amazing data, which you can freely download on this website, showing the latest trends in gas emissions for, on the left, carbon dioxide, and middle is methane, which are drastically increasing. Then for carbon monoxide, which is not a greenhouse gas itself, but contributes a lot to the greenhouse gas formation. That's generally trend is decreasing. And then the same for ozone, but or it's stabilized or decreasing for at least most of the northern latitudes. But we don't have the measurement anymore from there because the instrument broke in 2008, 10. And then I just want to emphasize two other very important greenhouse gases, nitrous oxide and sulfur hexafluoride, which has basically tripled over the past years. So, and that's just to put you in context, the global warming potential of sulfur hexafluoride is actually more than 23,000 times higher than carbon dioxide, and it's only produced from the human or anthropogenic activities and stays very long in the atmosphere. So the number 4.4 environmental issues are the anthropogenic sources, and please correct me or add me. So transport, of course, especially to the urban areas, where in the winter some cars have stuffed tires. Then about road dust, we have heard a lot of talks here, and who basically experience Reykjavik in March or April is very familiar, especially in these lowland areas. Then it's a lot of building constructions in Iceland, also important source. Then fireworks, I think actually the highest PM 2.5 ever measured in the world was measured in Reykjavik during the New Year's night. Then we have cruise ships, and that's really increasing in number every year. So at least 300. I haven't unfortunately found the exact numbers, but I know it's at least 300 ships which are not only dogging in Reykjavik, but also going to Westfjords or Akureyri. Then I mentioned the wetlands, which are massively stripped with the ditches, and the ditches are over 40,000 kilometers long, and this is the source of the greenhouse gases. Especially, it depends on the level of a waterbed, if it's CO2 or methane, but this is, I think, I expect this to be really enormous source of additional greenhouse gases, which would be normally stored in the wetlands. But there are just so few sparse measurements. So, and I'm not, unfortunately, the one who measures it. So, but there is something about it. And then we have also houses are heated here with the geothermal energy, and side product of it is the pollution caused by hydrogen sulfide. And then, for example, there are no volatile organic compounds measurements at all in Iceland, if I'm correct. And just now came actually another source, and that's the POPs, persistent organic pollutants, which I'm missing in this list. And I think we have quite good measurements around. Now I remember Johanna Thorasius from Met Office was doing these measurements. So yeah, that's an additional air pollutant. And yeah, this is the slide for the additional sources. Am I not already speaking too long? So yes, this was really nice from Richard to see that he pointed the long-range transport of air pollution, especially emissions from the wildfires, either in Canada or United States. And these plumes are very often passing Iceland, and even Icelanders notice much better air pollution from these sources than they would actually recognize from local dust storms. I'm sorry to say it, but it was a lot of said about these plumes when they arrive to Iceland. Then we also have our own wildfire, small scale, happening definitely on annual basis, and also related to the volcanic eruptions, because the lava is burning a lot of mosses and biomass around. Then, and again, please correct me, there is a natural degassing of volcanic areas, even though there is no eruption. So you can have really high CO2 emission, for example, from Katla, although it's not erupting. And I'm not sure about CO2 when there is no eruption, if it's also the gas. No. Okay, so I will correct this, and not sure about other gases neither. Then very little, at least to me, is known about the sea salt emissions and the other emissions coming from oceans, like dimethyl sulfide, which is important precursor for sulfur dioxide, and of course, in terms of further condensation and in terms of climate impact and negative climate forces, and then carbonyl sulfate and methyl chlorides, which are very important gases. Then other source source like long-range transport, so of Arctic haze in the spring. Not sure if anybody has focused if it's reaching Iceland in the spring or not. Again, the VOCs measurements, and I am not very familiar with the nitrogen oxides measurements in Iceland. Are they mainly focused in the cities, right? Yes. Yeah. So, and tropospheric ozone measurement, there is one, but unfortunately also only city, because we know there are much higher concentration higher I'm too long, higher in the atmosphere, higher in the with elevations, and of very surprisingly high levels over winter in Iceland when you have not much sunlight. Just quite important fact. So for this conclusion, so for the CAMS project, our focus is that we want to enrich the sparse PM measurement network with adding these 3 stations. Data will be available online and also nicely processed in a web application. For the greenhouse gas in-situ measurements, important many new stations are built, so we can provide data to CAMS for the products. And when it comes to forecasting, I'm not much familiar, but I know of the dust forecast, and there are some SO2 forecasts for the volcanoes, which obviously are not captured by CAMS at all. And you can see that here. And this is the dust model. And yeah, and here are 2 slides for we were curious with this survey to see what if Icelanders heard about CAMS products. So you can see it's a little bit more than half that they did, and this questionnaire will have more responses after this workshop. And then we also asked there which CAMS products are you familiar with, and you can see the level is rather in the like how to present it, in the very low. The level is very low. Okay, mainly, yeah, you can see it here. And the other questions were in which air pollutants would the Icelanders be interested, and you can see clearly dust and volcanic ashes of high interest, but and particulate matters of all sizes, but also the gases. And which products would Icelanders be interested? You can see regional air quality monitoring, global atmospheric emission data set, and greenhouse gases emission monitoring. And that was the last slide. Sorry for that. So, and this is from our desert this summer. Thank you.
Thanks a lot, Paula. If you don't have anything to pick up on in your country now, I'm surprised, because that was a really comprehensive list and a good overview.
Yes, thank you.
Thank you. Are there any questions to Paula from the people in the room? Because I saw there was a couple of questions or comments online. So I think one of them was from Mark about the emissions or the data available for the CO2. Mark, are you there? Maybe you can ask your question yourself.
Yep. Yeah. So yeah, the question was, I mean, just in terms of the degassing emissions from volcanoes. So we have an emissions data set for outgassing from volcanoes provided by Chalmers University, and this is based on NOVAX, and they also use some Sentinel 5P data now. And I don't know if Iceland volcanoes are included in there, but if you have other additional monitoring of those kind of emissions, it may be something that's quite useful to make it more comprehensive.
Yes,
you have to come here. we have Melissa Pfeffer here from the Icelandic Meteorological Office and the expert in the volcanic gases measurement. So she will comment. Thank you.
Where do I speak?
Yeah, you don't
Oh, okay.
Yeah, no, you can stand here because then
Okay.
everyone can see you.
Yes, so we're part of the NOVAC consortium. So our scanning DOAS data comes into the database that's hosted at Chalmers. Their winds, though, are not, their winds don't work at all for Iceland. So our data is coming in, but if you're using their winds to get the scans calculated into the fluxes, it doesn't fit very well.
All right. Okay, that's good to know. Yeah, I can check that with the contractor.
Thanks. Anyone else online wanting to ask something? No. Then I think we are ready for our next speaker. It will be Bojan Vetovic telling us about the DREAM model set up from Iceland.
Thanks. Just it's me to. Session. Okay. This one.
This.
Yes.
Here.
Okay. Hey, hello everyone. My name is Bojan Vetovic from National Med Service of Serbia Research Department. I'm going to present you recent findings from group which I belong. And you can see here the list of people heavily involved in all of these results. And considering the diversity of the audience here, I would focus more on the modeling concept, since Nichko already presented a lot of results in this morning session.
Can
So,
you please share your slides? They are not visible online.
well,
I have to share it through
you have to share.
But we are recording.
Oh, okay.
Sorry.
And then, no. Okay.
Thank you. Perfect.
Thanks. Okay, the concept of numerical weather prediction model, actually, what does it mean? It means that we numerically solve the equations that describe processes in the atmosphere. So actually, if you know actual conditions for the atmosphere, and then if we obviously know the rules, the physical laws that governs the processes in the atmosphere, that allows us to calculate the future state of the atmosphere. So in addition, coupled numerical atmospheric model with the dust model means that we have separate numerical models for simulation of climate system for atmosphere, and then truly emptied the model for the dust processes in the atmosphere, in which these different models interacts in every model step integration. So the concept is to solve all of these kind of nonlinear partial differential equations. And in order to solve these equations, the typical approach is so-called penny distance approach, in which we divide the domain in both horizontal and vertical direction, making these grid points, and then calculate all of these kind of equations for every grid point. So these equations gives us prognostic values in every time step in the model, both for the atmospheric part of the model, but also for the concentration, dust concentration. So to understand and to properly model the dust aerosol transport, model should have cover different kind of processes in the atmosphere, from microscale turbulence and emissions, and then to long-range transports, and even climate aspects, and etc. So for the small-scale processes, we need very high model resolutions in order to resolve these kind of processes. Just to say, the model resolution is actually the distance between these grid points. Okay, just for that, as an example, if you want to increase your model resolution 2 times, that requires 8 times more processors. Why? Because you have double the more grid points in X direction and Y direction. And then if you do that, you will want to have the more vertical levels in the atmosphere to resolve vertical motions. That's additional 2 times. So you will end up from 10 to 5 kilometers with 16 more times CPU. So for example, current ECMWF operation global model resolution is about 10 kilometers. Sorry. So depending on the research goals and considering nowadays computer resources, mainly there are few branches in modeling the atmospheric gas processes. So modeling of the long-range transport, it requires models of, let's say, 10, 20, up to 100 kilometers. And then if you want to resolve processes such like intense local dust storms, you need to use short-range non-hydrostatic regional models. And to illustrate the problems we are facing with these computer needs and let's say resources, but also to show you how different model groups and models can complement to the whole story. I'll show you the dust storm in mid-July, 7 July 2022. It was intense dust storm over the whole Iceland. looking to the left side panels, you can see the surface ice concentration from the CAMS IFS system, which I have to say is very good and very reliable modeling tool, especially because it involves a lot of other aerosols, but also in chemistry, etc. But due to, let's say, relatively low model resolution, it somehow didn't focus the local dust storm over the Iceland. On the right side panel, you can see our GIM Iceland model results for that specific date. So what's the story behind? Already said, motivation is, since the Iceland represents the let's say, most important European source of mineral dust with frequent intense dust storms. That was the first thing that motivated us. The second thing is that really almost often you have surface dust concentrations that above the limits prescribed for the, let's say, described as a very potential risk for the health, but also for the other sectors like transportation and etc. So our motivation was to develop a system which is capable to focus these events and which could be used both as early warning system for that, but also as a reliable tool for the climate assessments. So just schematically, representation of the model. The model can simulate all major processes in the atmosphere, starting from the emissions from the desert soils, then turbulent mixing in the atmosphere, then vertical advection, horizontal advection, and to the ending processes like removing these particles from the atmosphere through the processes of the wet and dry dust deposition. Here you can see the model resolution, model domain of our current operational model, which is roughly 3.5 kilometers. But our intention is to even go to the 1 kilometer resolution for this region. So what are, in our opinion, crucial things to, let's say, to properly focus or properly simulate the processes of the small processes, especially from the Icelandic dust sources? The first thing is to define dust source map of soils capable to have enough exactly particles to be lifted by the strong winds. And in order to do that, we're using wide spectrum of soil information such as land cover, silt and clay content in the topsoil. And in this case, it was, let's say, very important thing is that in Iceland, you have so-called dust hotspots. Some regions emit by far more dust than the other regions in the Iceland. Another thing specific of the model is that dust concentrations is calculated for each particle size and each model point and each time step. That means actually the online modeling. And we also implemented the variable particle size distribution, which means that the different particle size distribution is implemented for each dust hotspot. And also active soil moisture and snow cover are included in model in order to suppress unrealistic emissions during the, let's say, wet and very cold conditions. But more about that, you can find our paper published 2 years ago. So very valuable and crucial information was made with collaboration with our friends from Iceland, first Tolly and Paula. And we really excessively use the observed values, observations from these dust sources over the Iceland. So the starting point was the soil erodibility map, which represents the intensity of the soil erosion based on 2010. Then among all of these classes of erosion, we choose actually these three: extreme, severe, and considerable erosion. Then overlapping this with information about dust hotspots, ended up with, after remapping, with final dust source map to be used in the model. And you can see here for the two different model resolutions, how actually model resolution affects the resolution of what you have in model, how these hotspots are represented in the coarser and in finer resolution on the right side panel. So another thing is silt and clay content, also from the measurements from the people from the colleagues from the Agricultural University of Iceland. And silt and clay content is actually one of the most important input parameters for in the emission scheme. Another curiosity, almost all, if not all, nowadays modeling systems use conventional particle size distribution. Actually, how the mass is, let's say, distributed over different bins. So in every grid point where you have dust mask is pre-described particle size distribution. So according with measurements from the dust hotspots in Iceland, we applied or we implemented that every dust hotspot has its own particle size distribution, which reflects more realistic situation than. So after all of this have been let's say in model, here are some results. This is a dust event representing the relatively local scale dust storm in Iceland. Started on, let's say, 10th of September 2011. And it started by activating multiple dust sources over the Iceland. Let's say the most severe event occurred on September the 12th. And you can see for this bottom, let's say, plots modeled out, that model was able to let's say to forecast such events. But another thing is model was able to remove all of these particles next day in the, not all, but drastically reduce the concentrations in the atmosphere. Another kind of, not kind, but verification was using the Calypso satellite products. So you can see the Calypso path. Then we made the model dust concentration along this path. Then Calypso on these two middle and the right plots, you can see the Calypso catch this type 3, which is aerosol, and this aerosol subtype was dust. So actually confirmed that we, let's say, successfully focused this event over this region, and specifically over the Reykjavik. On the lower plot, you can see the comparison between the modeled surface concentration and observed values. So the blue bars are modeled, the red bars, orange bars are the observed values. So model was able to catch the instant increase, but also increase in concentrations, but also the decrease in concentrations in, let's say, matter of hours. But on the here in this area about 7 a.m. that morning, you can see here this might be false alarm, but it could be another thing. called the double penalty problem. So when you go to the higher resolution, that problem actually first was recognized in verification of precipitation, because precipitation field is highly non-homogeneous, both in space and time. So if you have coarse model resolution, coarse model will produce some value of precipitation over a wide area. And if you have observation point within that box, you will say, okay, model performed well. But this coarse resolution model cannot produce such intense amount of precipitation. The same is like for the dust concentration, highly non-homogeneous field. So when you use very high resolution of model, the whole event could be really good predicted, but somehow shifted in space, let's say, few kilometers. And if you do not have observation point in that specific grid point, that will produce false, not false, but that will lower the scores of the model. Another case here was the case of the long range transport, unlike the first one. So on the top panels, you can see the visible and true color reflectance and AOD from the from the MODIS Terra and Aqua satellites. So these plums starting from the southern part of the Iceland are catched on the, let's say, it's clear from this. And thanks to my colleague and good friend Anna Vukovic, who was, let's say, who produced actually this global sand dust storm, the global map, let's say, of potential sources. You can see that at any time to the year you have about 20% of surface all around the world that's capable to emit the dust particles. In favorable conditions like high winds and very dry conditions, you can see on the right side, almost 43% of the globe can produce are dust productive actually. And on the lower graph plot, you can see a lot of these points are in the high latitude region. So knowing this, implementing this information in our model, new version of model, which is called the circumpolar model. That's actually regional model, which is centered on the North Pole. And using these source maps, you can see on the bottom right panel the forecast of the dust emissions, both from Icelandic, but also from other sources like Greenland, etc. And just to quickly conclude, at least some of conclusions, that global models are very reliable modeling systems like ours, and the main source of information for the global scale dust transport and global scale climate assessments. And you have to take into coordination that like modeling system like CAMS include a lot of other aerosols, but also the chemistry. So they are very, very reliable systems. But limitation is, at least for the dust emission from these relatively small, let's say, dust sources and short-lived small scale processes, they are unable to simulate small local scale atmospheric processes such as local dust storms. On the other hand, coarse regional models with 10-15 kilometers resolution are good for synoptic scale processes and emissions from relatively large desert areas, but also limitation is lack to simulate small scale dust storms. And finally, the high-resolution non-hydrostatic regional model with specially developed dust masks are capable to forecast and simulate these things, but they have relatively small model domain. You cannot cover the whole globe or even whole hemisphere with model with resolution of 2 or 3 kilometers. So complementarity of these models should be, at least in my opinion, the right way for the final goal. And thank you very much for.
Thank you. Yes, there are questions.
Just about slide 14.
Slide 14. Okay.
I forget if you mentioned it, but for the bottom left figure, you
Mhm.
talked about the difference in the time of day
Yeah,
prediction
Mhm.
or the time-based prediction for the model versus observation, but like the model also seems to predict like a 10-fold higher concentration than the observed. Is
Yeah.
there? Do you have any like
Have in
explanation
mind
or thoughts
this-
for that?
Yeah, having in mind that you have observational core, which are hourly averaged.
Okay,
And this is the
At full hour, what do you mean by that?
Exactly the full hour. And then what we know from observations that averaging over the 1 hour, you can find, at least you can find in paper from Anna Vukovic from Arizona, Habub, so-called Habub, you can find that even the concentrations are greater than 20,000 micrograms per cubic meter, surface concentrations, but within very limited time, interval of time during this hour, So this from part of the, let's say, problem is comes from that, from averaging things.
Okay, so they're not really the
Yeah,
same.
and I wouldn't
thing.
say I
That's
don't know.
their-
Yes, and not a single model in the world is really perfect and will give you the perfect exam, exact, surface concentration. But this increase and decrease will really suggest you that something, intense gonna happen.
Have you tried to classify those events if there are special meteorological conditions behind it, if there are prevailing winds from?
Actually, a lot of these dust events are, at least in Iceland, are caused with the cyclonic circulation. Because you have constant cyclone tracks along the North Atlantic and even cyclogenesis near the Iceland. So the most of these dust events are generated actually by the cyclonic activity. Any other question?
Yes, Leonor has one online, and it's about how you evaluate the nesting in the microscale models. So maybe Leonor, if you're online, you can ask your question yourself also.
Let me see. Thank you, Bojan. Very interesting presentation. And I think it's very interesting when we think of value chains that we have different processes and not all the processes are included in all the models. Yeah. So I was wondering if how you see the possibility of having a sort of a nested type of models, because in the CAMS regional, there are some of the regional models that have, in fact, soil resuspension, and they have the agricultural dust, they have the crust, so that we have the full understanding of the different types of soil types, and then put it in so that we have a basis for comparison on a way, and the sources are there, and seeing if it is possible to do some type of nesting or putting those together and inter comparisons. Have you considered that?
Yes. Look, in this model setup, we use actually the soil, the database for the soil properties are like 100 meters resolution, So
that's good.
Yeah, high resolution of data, but you have to average somehow that on the box of 3 by 3 kilometers, and we'll definitely lose some of the informations because of that. But was the problem with nesting from this HLD, let's say high latitude dust regions, and that, unlike the yes, we have the nested system for the dust transport from the Sahara and etc. You know, the large desert areas, and there is really meaningful to have the coarse model and then the nested model to, let's say, to incorporate the information of the coarser model. But how would you nest the model in Iceland when you do not have the very how to know boundary conditions for the nested model when you do not have special dust masks for the whole domain, you know?
Yeah, but that's the part that we can discuss, I think,
Yeah.
because I think the soil distribution, and especially because we're getting more and more in arid areas, and it's important to get to those. So it would be an interesting exchange anyway to begin thinking how it can be done in the different scales. It's different, the global CAMS model from the different regional models, and then we can go down a bit more in detail when we get into national models like the one that you are having then over Iceland. Yeah, thank you.
This was more question for my colleague Anna Vukovic, since she's the expert for that, but thanks you for, very much for asking this question. Thanks, bye.
Okay, thanks everyone. Very good. And now we switch back to online presentations again. I'll stop sharing. There it is. And I think now our next speaker would be Amy Swidworthy at CRC in England. She will talk about how local air quality forecasting is used in England and how we can use that as an example also everywhere. Okay, so Amy, the floor is yours.
Thank you, Anne-Marie. I'll just share my screen. Can you see that okay?
We see at least your overhead with the white.
Yes, excellent.
Yep. Okay, yep.
Good afternoon. So my name's Amy Stidworthy and I'm an Associate Director at Cambridge Environmental Research Consultants in the UK. So I and my team work on air quality modelling projects and air quality model development. And I have particular responsibility for CERC's forecasting and data services. And I also work with Thomas and others in the CAMS user intelligence team. And I'm very happy to be with you at this CAMS workshop for Iceland today, even though I'm only online. So at CERC, we operate a range of different air quality forecasting services. So they're all based on high resolution air quality modelling using CERC's ADMS urban pollution dispersion model. And they all use CAMS data as input. And we're finding in the UK right now that there's a particular focus amongst policymakers on how best to communicate with the general public about air pollution issues. And we're finding that they're increasingly interested in using local air quality forecasts as part of the sort of portfolio of information that they provide to their local residents about air pollution. So in my presentation today, I'm going to give you an overview of the services that we operate and how they work. And then I'll tell you about how we use CAMS data. So our original air quality forecasting service was the London Air Text service, which was launched in 2007. It's still running and it's supported by London local authorities. It's a 3-day forecasting service. It's updated twice a day. And you can see a screenshot of the website here showing a very polluted day, which is thankfully quite rare in London. We use the UK's 10-point air quality index scale, and there are separate forecasts for nitrogen dioxide, ozone, PM10 and PM2.5. And as well an overall forecast, which is the highest of all pollutants at every location. So each of the London local councils is an alert zone, and then we issue alerts by text message, email, and on social media if the forecast is moderate or worse. And people can just sign up for free to receive alerts. And at the moment, we've got an ongoing project to update the service and make more and better use of the data for specific uses, which is very exciting and should lead to new services based on AirTex data later this year. So, for example, things like low pollution walking routes and forecasts specific to individual education and healthcare settings. So our Riga service was developed in partnership with a local Latvian partner and with Riga City Council as part of a CAMS use case project in 2018. It's now fully supported by Riga City Council, and we based it on London AirTex, and it also sends alerts to subscribers. But this uses the European Air Quality Index scale, and we generally designed it for the needs of the local stakeholders. In 2019, we developed a service for Greater Manchester and that's also still running. Here, instead of having a dedicated website, the forecasts are embedded in the Transport for Greater Manchester's Clean Air for Greater Manchester website. And right now, we are working on a brand new service for the City of York in the UK, which is again similar to the London AirTex service, but very much designed according to local requirements. And that's going to be launching next month. And we're also got a couple of other services that are in development at the moment. And there are also some services in Hong Kong and Barcelona and France, which use CERC's ADMS urban model. So I just want to talk to you a little bit about the high resolution pollution dispersion model, which is ADMS urban, which is CERC's model. It's a comprehensive system for modelling air quality across large urban areas, cities and towns at very high spatial resolution, so often about 10 metres or less. It's a practical urban air quality model, and it draws on recent research to incorporate the latest scientific understanding and explicitly represents the full range of source types that you get in an urban area, and takes account of things like the complex urban morphology, things like street canyons, and gives you output of short and long-term average pollutant concentrations from street scale to urban scale. And you can use it with weather forecast products like WRF for air quality forecasting. It can be used with the CAMS European or global forecasts to take account of long-range pollution transport. And then for larger scales, you can also link it to regional chemical transport models like CMAC, EMET, or WRF-Chem, the type of models that are used in CAMS. So these are just some examples of high-resolution air quality maps that you get using ADMS Urban. So on the left, we have a map of annual average nitrogen dioxide across all of London at 10 metres resolution. And you can see the very high spatial variation across the city, and the highest concentrations in the centre and lower concentrations around the suburbs. In the middle is a PM10 map over a much smaller scale, showing the detail around the roads and junctions. And then on the top right is an annual average NO2 map for Barcelona in Spain, again showing the high degree of spatial variation around roads. And then on the bottom right, you can see some results from ADMS Urban linked with the CAMEX regional model for Hong Kong, showing again annual average NO2. So next, I just want to show you some more recent results from ADMS Urban, this time linked with the EMET model. These are maps of annual average NO2 for Ireland for 2018, and this represents work done by CERC and the UK Centre for Ecology and Hydrology for the Irish Environmental Protection Agency for their Air Quality in Ireland 2022 report. And in the centre, you have a map of all of Ireland, and then zoomed in maps around it that show selected urban areas in Ireland. And of course, the largest urban area in Ireland is Dublin, and you can see that in the NO2 map. And these are maps at 20-meter resolution, I believe. So this slide is about how we produce air quality forecasts for London. So the ADMS urban model, represented by this map on the right and the little icon here, it models the dispersion of local sources in great detail, but it doesn't account for long-range transport. So in a forecasting context, we use CAMS for this. So we feed the CAMS European Ensemble forecast for the next 3 days into ADMS Urban, along with the very highly detailed local emissions inventory and the weather forecast data. And then we also use some local measurements to calibrate the forecast. And then that high resolution concentration output for the 4 key pollutants across all of London is then converted to air quality index levels, as I mentioned earlier. And then this information, together with the health messages that accompany the different alert levels, is sent out to subscribers in lots of different ways on the website, as I showed you earlier, but also by email, by text message, by voicemail, and by Twitter, now called X, of course, and also by web API, so that it can be integrated into other services. Now some more specific information about the CAMS products that we use. So for air quality, we use the CAMS regional ensemble forecasts for PM10, PM2.5, ozone, nitrogen dioxide, nitric oxide, and non-methane VOCs. We have Python scripts that download this data in NetCDF format from the atmosphere data store that Richard talked about earlier, between 8 AM and 11 AM each day. And then, as I mentioned earlier, our 3-day forecasts are updated twice a day. For the 7 AM update, our calculations begin at midnight. So of course that's too early for CAMS. So we use the CAMS forecast from the previous day. And then for our 7 PM update, we begin our calculations at midday. So we can use the CAMS forecasts for the current day. For the Riga service, we're also using the CAMS pollen and UV forecast products. For the pollen, we download it in the same way as the pollution data, using Python to access the ADS API. This gives us pollen forecasts in units of grains per cubic meter. And then a local expert aerobiologist in Latvia helped us to convert this to a 4-point index scale from low through to very high, consistently with other pollution and pollen information, I should say, in Latvia. And then for the UV, we extract the CAMS total sky cloud adjusted UV index for a grid point near to the centre of Riga using a web map service. And that returns a 3-hourly 5-day forecast in JSON format. And then the Riga AirTex daily UV forecast is the maximum of the 3-hourly forecasts for each day. So I think we might have made up some time. That was my quick tour of how CERC uses CAMS data in our local air quality forecasting services. I hope you found the information interesting and useful. Maybe it's given you some ideas for what you could do with CAMS data. And I'm happy to take questions, or you can send me questions by email. My email address is here. Thank you very much.
Thank you, Amy. It's very nice to see how you have built up that and how it's downscaling using the CAMS data in other countries. Are there questions in the audience, Amy? Anything online? No, as far as I have seen, nothing online. Yes, Paula.
It's just my personal interest. Is there any application that would include also the household burning sources, especially for let's say central, southern, and eastern part of Europe?
So So in terms of local household burning, we would include that would be included in the emissions inventory that we are modelling for London. In terms of emissions from Southern Europe, we would rely on CAMS for that, the long range transport of that pollution coming in through the CAMS data.
Amazing. So in terms of the London smoke type still exists?
There is actually domestic burning is of increasing concern in the UK because it's become very fashionable to have nice wood burners in your home because it's cozy, which in urban areas like in London, it's actually causing increasing problems. So a lot of the local authority policy action in London at the moment and in other urban areas is actually focused on particulates and on encouraging people to use clean fuel and to not have wood burners in urban areas. But yeah, it believe it or not, it is actually still a concern.
Yeah. Okay, thank you.
Thank you, Amy. Just for curiosity, is that a problem in Iceland as well? No, you don't have too many domestic.
Yeah, well, we don't have the wood here, right?
Just to add to this, so I work for the Sea Lamp team, so it's one of the CAMS ensemble models. So we do have a dynamic model for residential heating that's based on the forecast temperature and covers for Europe. So I think it's part of the background at least.
One is geothermal, I guess, instead. So that's good. Perfect comparison. Makes it easy.
Yeah, great to know. Thank you.
And it's also something we can take up in the discussion again if there are other specific things we can dive into. Thanks again, Amy. Our next speaker would be Sarah Bassard from WMO, and she will give us some insight of the air quality activities that is done at the WMO. Floor is yours, Sarah.
Oops. I hope that you can listen to me.
Yes, we can hear you, and we see now your screen. Yes, perfect. Thank you.
Thanks a lot for the invitation at first. It is my pleasure to be online in this workshop. I'm Sarah Bassard. I'm scientific officer from this WMO Science and Innovation Department, that is the research branch of WMO. And today I want to introduce you a little bit the air quality activities at WMO, and in particular the ones that are connected with this Global Atmosphere Watch program. At first, because most of you sometimes are asking this question, I was asking this question when I arrived to WMO. What is WMO? Is the United Nations agency that is specialized on weather, climate, and water. Is supported by 193 members. This means countries. It's having the headquarters in Geneva, in Switzerland, where I am today. There are more than 300,000 experts involved in our discussions, and we are co-founder and host agency of the IPCC. In the picture, you can see our current Secretary General, which is Celeste Saulo, and also the President of WMO, which is Dr. Al-Mandous. And another thing that is interesting for you maybe is to understand how it's working WMO. WMO is working in research, which is science and innovation, is working in infrastructure, meaning standards for exchange data and information between countries in an harmonized way, but also in the development of services, meaning early warning systems, disaster risk alerts, and other type of services demanded by the countries. It's in this context where you can find the Global Atmosphere Watch program, that is the program that is dealing with atmospheric chemistry research at WMO, but also there are specific programs for climate and weather research. And one of the things that are new from the last year, and maybe you are not aware, is this UN initiative that is called Early Warning for All. And it is a UN effort to try to provide to all the countries systems for early warnings. And these early warnings is a huge list of hazards that includes weather, hydrological, any kind of hazards. And one thing that is interesting in these conversations on air quality is that in this list of hazards, it is considered sun and dust storms, wildfires, and also air pollution. Then it's important to understand when these elements of the atmosphere becomes a risk, to propose the mitigation measure that in that case is this early warning concept. And going now to WMO Global Atmosphere Watch Program, what this goal really dealing is to promote research for enable atmospheric composition services. And when we think in atmospheric composition services, we are thinking also in the services connected with sun and dust storms, wildfires, air pollution, volcanoes, any kind of phenomena that is connected with the composition of the atmosphere and is having implications for society. In this case, we are doing a very strong emphasis in the components connected with aerosols, reactive gases, stratospheric ozone, because the link with the ozone hole and the greenhouse gases. Also here, I want to stress that GO is promoting science that should be in an applied framework, meaning that all the research that we are promoting is because we identify some societal needs that needs to be covered. And in a specific, the Global Atmosphere Watch is connecting researchers around the world. Now we have experts from more than 100 countries. And the main activities is to keep and apply this long-term systematic observation data set that it is used basically for global assessments. And this is the context. We need to coordinate at global scale all the measurements and information to have a standardized and harmonizing information that allow us to do these global assessments. In this case, we are doing a lot of emphasis in the quality of the data, meaning our standards of quality assurance and quality control are really strict because we need to ensure the quality of the information to try to deliver the best products that can be used for the services proposed. And when we think in services, in GO, we are working in different areas like conventions. And in that case, the one that is more interesting for you probably is the Long Range Transport Air Pollution Convention. That is an international convention for address the long range transport pollution. But also we are having collaborations connected with other conventions like the Montreal Protocol that is dealing more with ozone and all the components that favors the ozone hole, the Paris Agreement with emissions, but also we are doing focus in crops, health, climate change mitigation strategies, and also warnings. And this is something that is covered some of the talks that I listened earlier today from the different speakers. And this is basically the strategic plan of GO. We are having 4 pillars, and the 4 pillars are connected with research infrastructure, meaning observations, applied research, meaning what are the best solutions that we can propose for the identified gaps for a specific application area, the promotion of science to really develop services useful for the users, and here there is a good workshop for gathering feedback and to understand the needs of the people. But also we want to promote capacity building, just to promote the best practices on the use of this information and the production of this information when you think in monitoring, for example. And here you have the distribution of the observational research infrastructure coordinated by GO. As I mentioned, we are doing a lot of emphasis in the quality of this data. And as you can see, there are some areas of the world that are better covered than others. There are some limitations in observations in some areas. In Europe, it is well organized. And specifically in Iceland, we have 3 sites that are part of this Global Atmosphere Watch network. But also we want promoting some discussions to try to fill the gaps, integrating other sources of information like the famous trendy topic that is the low-cost sensors and how we can integrate satellites and national air quality networks in this context of providing the most accurate information. Also, we have the concept of services, and we are doing services specifically for different application areas. We have the measurement model fusion for global total atmospheric deposition that is basically focusing in deposition to ecosystem and crops, agriculture basically. And also there are specific activities connected with climate action, like the integrated global greenhouse gas information system that is focusing into providing information on the emissions connected with greenhouse gases and cities. And also we have services, platform services for warnings and air quality. And here you can see the one presented in these talks from Bojan and other speakers today, that is the sun and dust storms, that is the sun and dust storm warming advisory and assessment system. But also recently we promote one for wildfires, which is the vegetation fire and smoke pollution, and for air quality forecasting and information systems. The main goal is to create a structure that allows us to provide some robust information and some standards that we can use to propose services for the different countries. And in that case, one of the most important things connected with forecast, it should be the model intercomparisons, is the way that we can propose some benchmarking activities to promote some standards that will be fair for all the countries around the world. And here you can see the distribution of the different activity windows that we are working now inside Go. We are having a specific comparisons for sun and dust storms. This is the yellow squares. Also for wildfires, which is the green ones. And then for air quality, also there are specific activities for really go to the discussion of performance and benchmarking activities that we have to impose at the international level. And this is the kind of examples that you can find. It's something similar to Copernicus website when you go and you can compare the different individual models of the ensemble. Copernicus global run is considered always in these model intercomparisons. If you go to the list of models, always you will see ECMWF, and then it's a way that also we can assess the quality of the product outside Europe, but also inside Europe. And this is the reference center for you for sun and dust storms in the area of Europe, is the Barcelona Dutch Regional Center. As Bojan mentioned, there is this experimental forecast for Iceland that is focusing really in the sources that are connected with the big desert in Europe, which is Iceland. And the kind of things that we are proposing is gathering all the models is allow us also to propose some probabilistic products. This is the example of the last week, this huge event that was hitting Canary Island and then arriving to Europe. This is the kind of products that are helping us to develop warning systems, because if you see in the image, here we have the probability of accidents of 50 micrograms per cubic meter, which is the reference for WHO air quality guidelines. And as you can see here, reddish means that all the models was predicting these accidents. But when you do the same exercise for 100 micrograms per cubic meter, we can see also that most of the models was telling us that a huge sun and dust storm was arriving to Europe and hitting Canary Islands. Then this is the kind of information that we need for the production of these early warning systems. And also about capacity building, we are coordinated with different agencies inside UN, but also outside UN, like ECMWF, Copernicus, ARC. The High Latitude Dust community is also helping in this effort. Then all the efforts are trying to be aligned and connected to really assess and provide response to the demand from the community that sometimes is challenging, but the community is super supportive. And always there are people that is willing to promote some exercise if there is a demand. And this is important for us. We need to know what the users need for proposing certain activities. And this is my last slide, I can say. And this is the type of things that we are doing to promote science and to promote the achievements of the community. We are publishing every year annual bulletins in different topics, the ozone and UV bulletin, the air quality and climate bulletin, and then the airborne dust and the greenhouse gas bulletins. They are available in the public library of WMO and you can download. But also we are trying to keep you posted as much as we can with the newsletters. You can subscribe if you want. You can take a screenshot of the QR and you can be subscribed to our newsletter. And there are many information that can be distributed through these communication channels. And this is the type of things that are interesting in air quality. This is one of the figures that you can find in the last air quality and climate bulletin of WMO. And this is the anomaly map of the year 2022 versus the climatology that is available. This is it's based on the CAMS reanalysis. And as you can see here, in the year 2022, we had this anomaly on PM2.5 levels, and it was connected basically with extreme events of sun and dust. But usually it's true that Iceland is a very specific area of a study, and there are more and more emerging research groups that are focusing in this high latitude dust. And why? Because high latitude dust is really something that is hitting Iceland. This melting of the ice cover is exposing new soils. And for me, it was interesting to know from Pavla this map of traffic, this alert system for road traffic, and to discover that now you are having some alerts specific for blowing dust that is really hitting your ground traffic. Then I will say that for you is really something that is starting to get more and more attention, and something that the community has to be aware. Also, you have a lot of activities with volcanoes, how is impacting that in the aeronautical sector, and also your contribution with the greenhouse measurements are really valuable for the Go community. And just I want to thank you, all of you, for being here, and happy Valentine's Day.
Thank you, Sarah, and thanks for reminding us for Valentine's Day. That was very nice overview and giving some insight in all the WMO activities, and also, yes, it was nice to see this linking to what you explained about the roads and everything. So it's of course it's high importance what's going on in the Arctic. So it's good. And there was also one comment online I saw, Sarah, for the microsensor. It's appreciate that you also bring that into context.
It's a really tricky conversation, I can tell you that. We are preparing now a new report, and WMO is promoting a series of low-cost reports. There are already 2 available in the library of WMO. And the new one is really focusing in the application of these new technologies, the application areas. And yeah, if you have contributions, discussions from Iceland to these conversations, it will be good for us to know, because we are trying to collect as much as we can information on how we can introduce these technologies in these air quality management discussions and forecasting systems. And yeah, it's a nice conversation, by the way.
Yeah. No, we also had this morning a talk touching upon that and bringing all these drones and things into systems. So.
I think that the important is to define the limitation of the application area of these instruments, but it's useful information. The only thing is to be clear on the use.
Yeah. But it's good that we can meet and discuss also, and I think it's an opportunity also to bring that up when we had the discussion. Sure. Yeah, Paula, you want to say something more?
I would just like to add, so thank you, Sarah, for your time, and I just would like to really emphasize that it was you, when you were the head of the cost action in dust, that you gave us the kind of trust and place to really go deep into the high latitude dust research, although the action was purely on Saharan dust, right? So
I have to say that you have a very nice group in Reykjavik for pushing things. It's really active community. Then all the credit is for you guys. No, I was only coordinating. The work was done by you. Yeah. And I'm super glad that the high latitude dust now is getting more and more attention, and it's climate implications what is important. Because yeah, I think that heat waves are hitting Iceland more regularly and more frequently.
Yeah, and also in the PM 2.5 analysis, country analysis map, you show these hotspots, which are obviously for Canada and Yukon, like this Alaska area. So that was interesting to see. So we have some representatives here. And the third point was, so is the Icelandic operational forecast already on the Barcelona website? Because I missed it.
I think that is not in the dashboard, unfortunately,
No, so it's
because there are some issues, technical issues, but the numerical data is there. You can download the numerical data, but the visualization, I think that at the moment is having some, remember, projections.
yeah.
It's always the same, dashboards and projections.
We are patient. Thank you.
Thanks again, Sarah. And now we are ready for a last speaker for today. And after that, we will have a short discussion session. So I will now give the floor to my colleague at NILU, Leonor Tarason. She will say some updates on this fair mode test exercise that has been run different places and bridged that to Iceland and Arctic regions. So the floor is yours. We can see your presentation, Leonor.
Thank you very much. That's very good. Well, it's a pleasure to be here. Thank you for the invitation. I'm Leonor Tarason, working at NILU, as Anne-Marie said, but I'm working also with Thomas and Amy in the uptake of CAMS products for a user community. And I'm also working with especially the policy applications. So we've been looking very much at different applications, and Sarah brought us into the more of a world part. And what I want to come back now is very much on this link between what CAMS does for policy applications, and that is this joint exercise that we have with FAIRmode. I don't know if you know about FAIRmode, but that's the Forum for Air Quality Modeling in Europe. And it's very much a forum of expertise, thinking in terms of what do we need in terms of modeling for supporting the implementation of the air quality directives. So it's very much into air quality, it's into the understanding what happens with air quality. And in that context is when we have this type of dust exercise, because we are seeing, as it was pointed out, more and more intrusions of dust into the European area and affecting, in fact, exceedances to limit values. So this is an exercise that we began last year. We began in April 23. With cooperation between the CAMS team, where my colleagues Paul Hammer, Anne-Marie is there, Svetlana Ziro, Renske Timmermans, Augustin Colette, and Bettin Ro, they are all working there. And then we have in the chairs of FAIRmode with Matthew Ross-Jones. What is interesting is that we have about 40 people from different countries. We have 14 countries, even Norway, which is not the natural. We have most of the countries that are in Southern Europe, but Austria, Belgium, and Norway are also included there. And we are looking at these dust interruptions. It's very nice to see both ECMWF, WMO with Sarah very much following this exercise, and the EEA, it's also interested on what's happening with the exercise. The reason for it and what we are looking at is the fact that in the air quality directives, in the current one, in Article 20, member states are requested to identify zones where exceedances of limit values can be attributable to natural sources, and they can discount that if they can prove that there are natural sources. This is something that now in the revised air quality directive, which is discussed, and we hope it can be approved now in the course of February. But it is there in Article 16, and it is still kept there, this possibility of understanding dust and saying that dust is not necessarily anthropogenic, which is a strange principle from the Commission. We'll have to discuss a bit that. But in principle, if you can understand that your exceedances are due to dust, you can identify them, and then you are having a legal possibility of counting it as non-exceedance. The member states now are using guidelines that were developed, in fact, in Spain by the group of Xavier Carol back in 2011. And what happens now is that those guidances, they were developed really before the time of CAMS. This is really the analysis that it is there, is that it is done in the basis of understanding the African dust load as something that comes from the difference between the PM levels and background levels, and doing that really in the days of exceedances, checking if there is air coming from Africa, and then checking the 40 percentile. It's very much developed for Spain, and now we need to really get into a better identification of best practices and checking if we can have some input for the review of the official guidance, which is something the Commission is thinking about. There is about time to review that guidance on how to do the identification of natural dust exceedances. So the purpose of this exercise is really identify the best practices of understanding what type of situations are under the influence of dust, Saharan dust intrusions, but also different types of dust, so that it opens a discussion on what do we mean by dust. And it has really the purpose to include some recommendations on a new guidance, and that the CAMS dust products maybe can be used for some of the analysis in the countries. So we do that really to increase the awareness on the dust products in CAMS, promote the use of those for exceedance analysis, and then compile experiences from the different countries on things that CAMS have to do better. It's really a dialogue platform, and the exercise, it's been mostly a discussion exercise where we ask for selecting, the countries were selecting an episode in 2022, and then identifying in that exceedance episode, identify the dust contribution with the current methodology, the one that they use from 2011, and then carry out an additional evaluation using some specific of the CAMS products. Then compare the methodologies, share the experience, and help developing what we call best practices and recommendations on how to use CAMS for deducting the natural dust contribution from exceedances to limit values into the air quality directives. The point is now compare current methodologies, understand what it is inside the model results, understand better what we mean by dust, and not really looking at compliance at the first stage, but it will be possibly a continuation of the exercise, looking more at the compliance capabilities. The episode that we looked at 2022, mostly because it was last year that we began, and it was the year where we had more data to compile. And it was really to allow some flexibility. We were looking at PM over the whole of Europe. We had an episode in March that was very, very determinant with a large number of exceedances, but there were other types of episodes, and it was not really, everybody could use the episode they wanted to use. So there was some freedom there. What was important is that we try to put then the CAMS products more easily available for everyone. And we develop a viewer with data of CAMS, the interim reanalysis for hourly data for PM10 and PM2.5 all over Europe. We had also all the forecast data on hourly data. We had the source receptor data from CAMS, that is the chemical composition that is available from both the IMEP and the TNO Lotus model. And then understanding also the chemical speciation in European city. Everyone could use any of the products, and we were having many different people using those. What was interesting here is that we have many different products from CAMS. We have the global dust product, which is a global ensemble of only 3 global models, and it has AOD satellite data assimilation. That product is different from the regional interim, from the regional forecast, which is an ensemble of 9 models at that time when we were looking at the 2022. Now it will be 11. But it has no data assimilation. And then we have the dust fraction values that are from the reanalysis. And that is the product that already has some data assimilation of surface values, and it has a direct part on the dust fraction. In addition, we put the total PM10 so that we could compare the PM10 with the PM10 that was only from the dust. The interesting thing here is that some of the countries, like Malta, said the resolution is not good enough. We need to have the viewer much smaller to get into that. And these are requirements we have to look into account and check. But we are very open to put the data out and see then what people are using. Some of the countries use the chemical speciation. In the case of Bulgaria, they had an episode in the end of March and the beginning of April, where they could see very large differences between the IMEP model and the Lotus Zero in how much it was allocated to dust for that episode in the city of Sofia. And that was something they were really very interested on checking, and brings me a bit into the differences between the models. Lotus Euros and IMEP are using different boundary conditions. Lotus Euros is having a specific dust, and uses really the WMO boundary conditions part, and goes to the sand and dust analysis, while IMEP is using the boundary conditions from the global. And that sometimes makes a bit of difference into the results. Also, what it is relevant is that Lotus Euros is having wind-blown dust from inside the domain, but only the bare soil part. And IMEP has the same part, but with a different characterization of the soils. And that also makes a big difference in the results that we are having. In addition, the Lotus model, in fact, has agricultural activities and has road resuspension as production of dust. And I think that understanding of what it is, it informs really what are we understanding by dust. And what we are seeing is that we cannot put it all together, that we have to distinguish between Saharan dust and maybe some of these differences of the agricultural, the resuspension, maybe the wind-blown dust from bare soils. That is more probably a part that we can see more related to climate change, and that we need to understand a bit better. So this is the type of thinking that we are doing. We're putting together the information and seeing that maybe we are not giving enough information. Let's put the models to separate this and get more insights on what we mean by dust. We produce also hourly data from the EEA directory and put them all together in a facilitating a Teams place where people could really get both daily means, hourly means of observations and the CAMS data. So they had all the data for the analysis presented in that web page that we opened for them. And then we began with interpretation seminars. We met in June, we met in October, and the interesting thing is that the countries were coming in and sharing their experiences with us. And we could see from there that there were misunderstandings that we could, in fact, arrange or think a bit more about them. And we began developing some ideas about what are the main lessons learned. We got into some of the lessons learned that really we could see. We had a good interaction with in Spain and in Austria. There were a lot of comparisons with observations and checking really the values of the results of the interim assessment report from CAMS and the forecasting data and the global data. And something that can be expected, but the interim assessment, the interim reanalysis has much better much better results with the observations, which is not strange because we have already some data simulation of surface data there. So this is really the product that we see may be a better candidate for the use of the CAMS products, looking at the actual dust contribution. We also saw that there are still large differences in the performance of the CAMS interim reanalysis in different areas, so we have to be aware of that. And then the analysis that was done in Hungary, which I was mentioning, on the chemical composition with these differences here, it's something that involves really that we need to understand much better what type of dust we are having. And unfortunately, my slide just moved a bit, because what I wanted to say is that it's not probably for qualification, but it's an interesting thing to look at, and maybe for the Arctic region. It can be interesting to look at the differences between Lotus Eros and IMEP and see what is a signal into the models or not, and what do we understand by dust in the different models. The other lessons learned that we got into was really the fact that if we use directly the CAMS products and the CAMS dust product, we are biased by the performance of the model. And then the different groups, Portugal made a bias correction, Malta proposed a different one, France made some intervals of confidence on how to use the dust contributions. And that is the type of best practices we are getting into, that maybe we need to see how do we qualify the model so that it can be used for that type of analysis. Links to the diapason, and those of you that has been in the cost action know very well what the diapason model is. But this combination of putting models with measurements, and especially using LiDAR information to understand the dust contribution, is something that we see as very interesting, especially when the diapason can be fed with some of the CAMS the interim reanalysis data. That can be a good way of proceeding and going further. So we are, in fact, in the latest part of the exercise. We had the 3 meetings of this on iterations, and now we are beginning to get into the conclusions and first lessons learned. We'll have a dedicated session in Paris in 2 weeks' time, with the Fairmount plenary meeting, which this year is back-to-back to the CAMS policy user workshop. And we are planning a final review on this first stage of lessons learned in March. And what I wanted to say a bit is that it's still possible maybe to cooperate and think how to work on this. And some ideas were really that a comparison of the DREAM Iceland model with the results from the interim reanalysis CAMS dust product can be interesting. Can be also interesting looking at this anthropogenic or bare soil component of Lotus Eros with your very nice DREAM Iceland characterization. The interesting thing here is that we have a dialogue with the different developer groups, and that we can enable better the national model development, maybe linking to some of the CAMS boundary conditions, but also we can improve the CAMS services learning from the national expertise. And you are in this national cooperation or national collaboration program, the NCPs in Iceland, which can be focused, or you are focusing exactly on dust, and can be something that maybe we can see how your contribution can come in. And I wondered if you also wanted to look what consequences are the use of the DREAM Iceland or the use of CAMS interim reanalysis data for the exceedances of limit values of PM10 in Iceland, if you have. Maybe you don't have any exceedances, and then that's not a problem. But if you have some exceedances, it could be interesting to look at the consequences from that point of view. So it's an open hand to cooperate on this part, and just wanted to thank you for your attention.
Thank you, Leonor. That was very nice presentation on fair mode, and I think already triggered some discussions in the chat. So, but are there any questions from the audience to Leonor? Yes, Paula.
I'm just curious. So do you have any potential number how much dust is in the atmosphere per that year 2022 in total above Europe?
About Europe, yeah, we know about these exceedances. Yes, we have that data. I don't have it in my mind now, but we have it available, and we have the interim reanalysis that it's already documented also. You can see it in, I can show you the document so that you can see what happened in 2022 in Europe. We have different approaches to this.
Excellent. And second thing is, I mean, excluding the dust in terms of health issues, it's not really like needed because of course dust is also really bad to the human health. So
yeah, I think what it is interesting here is that the more we look at this dust, the less natural it becomes. And we need to begin thinking also what is the level of trust and how robust can be our advice to policy on whether or not this dust component is something that we need to extract or is something we have to look at in more detail. The interesting thing here is that we still have the I am not sure if I am sharing the right way or if I am not sharing anymore. Have I stopped sharing?
Thank you. Slide, the last slide.
It's still there. Yeah, because I wanted to read the comments. Okay, but then.
Okay, but
I can. This is now like this. So in terms of dust, we really have to get into this discussion of what recommendations we want to give to the Commission, and this is really what we are doing now. So it could be good if you have if you have some recommendations, it could be good to count with you in the last meeting.
all right.
yes. Yeah, and also I think there was some comment in the chat concerning the model comparison and fair mode collaboration. Let's see, I take up the chat again. I have it also here. Yeah, so it was a comment. There are more comments. It was one from. Let's see. Oh, sorry about that.
I don't see the comments.
No, I take them up here. It was one from comment about the potential collaboration with the SDS and fair mode, which is also a start where we can look into. I think it's Slobodan, maybe you want to elaborate a bit more on what you see the collaboration with this and fair mode could be.
Yes, I'm here. Actually, I was just thinking that this kind of connection should be useful. But in the meantime, I was discussing with Sarah in a chat, and she said me that already some of our collaborators or members in SDS are in fair mode.
Yes. In that cooperation, and it is through Sarah really, and I think we need to think really what type of recommendations we want to have. Sarah was in this. We are now getting into this. We are in the 8th in Paris, and you were in the 6th when we were discussing in the 6th policy user workshop, Sarah, when we were discussing in Brussels. You came in and we said, well, yes, we are going to begin an exercise about natural dust, but what do we mean about it? And natural dust also, some of the storms can be mitigated, and we still have dust intrusions that come from bare soil and agriculture and the ones on resuspension. That is why in camps now, the Lotus group is really working into making sure that we can separate those. So we want to make sure that we can separate that part and that we can work with them. And I think it would be very useful to have it as recommendations to continue working on that, so that we can develop better guidance on that basis. So it's one of the recommendations we really need to get into. And I think it's important that we begin discussing this.
In fact, from also international perspective, I can tell you if there is a recommendation on how to assess the contribution coming from resuspension, this is really like a huge discussion in the Middle East, for example. And in Middle East, you can think Turkey, you can think about Israel, that is part of Europe, and how they can distinguish what is arriving and what is resuspended after the arrival, you know. And it's a nice conversation that we start with Leonor also. I can see that also in Iceland, this is potentially something that you have to be aware, how to distinguish what is resuspended, but from what is coming from outside and what is local, which is not easy.
No, but the local one has measures that can be put into account so that you don't get that resuspension. And this is really something that we need to address. And that would be the resuspension will almost be anthropogenic and your own responsibility. So that's very, very useful or very interesting discussion. And I think we have to work with that.
And maybe also a question back to this to Michaela or Pavla. How do you gap that into national stakeholders in Ireland, bridge that into the national stakeholders in Iceland? Some of you are here right in the room, but I would guess there will be more groups that could be interested in those discussions. And so this is what you foresee in the training you talked about. And
yeah. We
Yeah.
try to get more people, more organization involved in this discussion, and just spread the awareness about the camps and those activities. That was also the reason why we integrate this session into High Latitude Workshop, just introduce this and open discussion among Icelandic stakeholders.
But
it's in the beginning, so we need to work on it more and start to talk more about it and add more activities like trainings and workshops.
Because I think it will be very useful if you after this meeting go back and take some of the inputs from the presentations and see where you can exactly focus it on.
That's some content for the recording.
Yes. Very good.
I clearly see my task after this workshop that I will go through the recording and pick up.
Is there on the comment, we luckily can recognize our own dust here because it's of the volcanic origin. So we can recognize the Saharan dust arriving due to the high presence of quartz, for example, and we can recognize the Icelandic dust also in Svalbard or Balkan Peninsula, again, due to the totally different chemical composition and mineralogy. So that makes it easier for us. Yeah.
Anna, you have raised your hand. You want to say comment on
it? Thank you. Hello, everybody. I'm sorry, it seems like I'm sitting in the dark, but it got dark in the meantime, and I have only one little lamp on. So I just wanted to contribute to the discussion about what is natural, what is anthropogenic dust. It was an issue, I don't know, for several years before, and it was somehow discussed in the Sand and Dust Storms compendium, which was actually published by UNCCD, but it was derived from the collaboration of different UN institutions. So anthropogenic dust could be actually considered as the dust which comes from the major contribution is from anthropogenic sources. All other is mainly natural dust. Anthropogenic, the problem is anthropogenic sources can be figured out which one are those and can be assessed how much dust, and there are some couple of papers assessing what is the contribution from anthropogenic sources to some events, severe events, there were some case studies. But the problem comes to the point when you have to define anthropogenic source, which actually appeared as a consequence of extreme event or, for example, drying of lakes, or retrieval of the snow and permanent snow and ice, because it is a consequence of climate change. And then this is like indirect impact of anthropogenic impact on creation of sources. So this is actually the largest problem when you want to define anthropogenic sources, and from then you want to distinguish natural and dust from anthropogenic dust, how actually to resolve, or should you usually people from dust modeling community are not that much involved in climate change studies. So those sources which are not created directly by the impact of humans, like tillage or any form of land degradation, they are not considered as anthropogenic, but many of them are. For example, in Iceland, as a consequence of the retrieval of glaciers and erosion of the land surface as a consequence of that. This is also one question for land degradation, is the appearance of actual exposure of the soil surface, which was protected by the permanent ice and now exposed to wind erosion and water erosion, also the form of new form of land degradation, which could be considered as anthropogenic source caused by indirect impact of humans. So this is very complex question to assess natural dust to distinguish natural from anthropogenic.
Yeah, thank you. And I think it is the complexity of it is what it is interesting here, because we are seeing how the land use is changing because of climate change and also of our anthropogenic part. So the full analysis of the directive and how to change it. Now it's been a revision already of the directive, and that revision has kept the Saharan or the natural contribution as something that it can be extracted. But I think what it is interesting, this is a policy discussion, that the more we can identify, the more we can say where it comes from. So the source allocation of the dust, the more we understand where it comes from, the easier it will be to make a policy that is just afterwards. And that is a bit the role that we have as scientists in the camps, in the WMO or in FAIRMODE. We need to just identify what we are seeing is the reasons for the different dust, see that we have methods where we can identify with some level of understanding that we say, this is a confidence level where we can inform policy then, and then the policy can be revised. I don't think at this stage the air quality directive will not be changed. It will still say that we have natural contributions, and it doesn't explain what it is. But I think that scientists now have a duty to go a bit further and begin identifying those sources. And then from that, we can inform policy in the next stage. And that's a bit the cycle that we have to secure that we come to.
Thank you, Leonor. And I think in the interest of time here, I think we're about to reach closing time. And I hope that Paula and her team have picked up some things here that you can go back to your national level and different stakeholders to discuss and to bring further with the teams. especially also if you have noted down some points on your notes or postcards on what is there still need to be addressed in Iceland, how can CAMS contribute? That would be very helpful also for this contract to take back. We had some feedbacks from concerning the training and so on. But please, if you have 1 or 2 more points to put down on your cards before you leave, that will be helpful. And I also put,
yes, maybe like within only 3 minutes. If you have the points to say right now, it would be probably better. I don't want to take more time, like max 3 minutes. But if there is something that is missing or we have not addressed, that would be great to hear it now before we forget. All right.
Yeah, and then I think also we would like to hear Thomas saying a few words of closing remarks. That would be nice.
It will be coming up.
Yes, with you.
Not so easy because I think we are in the middle of discussion. It's not that we are coming to conclusions yet. We've seen a rich set of information today from different viewing angles. And the work that is still ahead is to disentangle and to see how best the complementarity can be implemented. So it's clear that the mandate of CAMS is not to do everything in every country. The mandate of CAMS is to do things that are pan-European, and where many or several countries have a similar issue and benefit from it. But definitely a better description of the source term of dust, of the specific dust in Iceland or in Nordic areas, is an element where CAMS can benefit, with the emission inventory being updated or being augmented, while the long-range transport from outside the Nordic area, so from Canada or Siberian wildfires or Saharan dust coming high up north, this is where CAMS is well established and well proven, and this could be an element that can be brought as boundary conditions or as additional information to services in Iceland. Where I think it's not easy is really involving stakeholders so that it is of immediate benefit. Normally it takes a longer time of learning from each other and better understanding the needs and understanding the capabilities. And this exercise that Leonor has reported about, analyzing best practice by examples of how natural dust can be subtracted. The best recommendation is a clear, unambiguous, and easy to implement one. And this is normally not what we get, because we see the complexity, the detail. That's what has been discussed. And therefore, it will take maybe another round to come to real practical conclusions that can be implemented into a directive. Yeah. Pavla, I have one suggestion for the interviews, because we have to iterate on them after this workshop. Maybe we can think about 1 or 2 cases where this interview could be a chance to involve a stakeholder in some more detail in the discussion.
Well, if I'm allowed to say, we already have some volunteers, right?
Okay, great. Yeah.
Or if they did not change their mind.
I did not understand the last sentence.
Yeah. So yeah, we are very happy to have some stakeholders, representative of the stakeholders here. And one interview, if you agree, would be the Thorstein Johansson from the Environmental Agency of Iceland, and basically the most known expert on air quality in Iceland. And
okay,
so he is here, and he would agree on.
Thank you so much. This is great. Yes.
And then, if possible, then we have experts from the Icelandic Meteorological Office here on the volcanic gas measurements. And Marisa said so she would also agree. Hi.
That's good. Yes. Then we can take it one step further in probably a longer discussion. Yes. I think that's a very concrete conclusion.
Okay.
I would finish by expressing our gratitude from CAMS to Pavla and Michaela and everyone involved, and to allowing us to hijack this high latitude dust workshop for the CAMS user interaction. I think it was beneficial, but also showing the complexity. So thank you for all this and everyone getting involved and contributing to the discussions. And maybe Pavla and Anne-Marie, you should have the last word in the room.
Okay. Yes. Thank you, Thomas. And thanks also from my side for your contribution to this CAMS part of the meeting. It was also a pleasure to listen to what you do on local scale for the dust here in Iceland, the high level.
Yeah, thank you, Anne-Marie. And I will probably invite Oti as well, because this is gonna be also just a closure for the whole high latitude dust workshop, which included this also as a session and largely a workshop. And really would like to appreciate everybody who came and presented in person. And I hope you have learned something new or something beneficial. And I really hope that the high latitude dust research and CAMS can mutually benefit each other. So we can bring some knowledge to you, and you hopefully can provide us with some not only knowledge, but of course products, and that could increase the awareness of the topic, like high latitude dust, right? Yeah, so thank you very much for being with us, and we will repeat this high latitude dust workshop event again after 1 year, exactly on the 14th of February, and we will have this special training on the CAMS here in Iceland in October or November. We will inform everybody. Thank you.
Thank you very much. Bye.